Chapter 7 uses another new calculator function, and it's also accessed from the second VARS menu. And we've got normal PDF and normal CDF, but we are only going to use normal CDF. And so that is for the area under a standard normal curve. And for the first one in the homework here, they always give pictures of 4 different scenarios. One is the shaded area is to the right of a certain z-score, then to the left of a certain z-score, and then in between 2 z-scores, and then outside of the interval between 2 shaded z-scores. And then later on after that, most of the remaining problems are the same thing, but it just says in words, area to the right, area of the interval between, area between, outside the interval, area to the left, area to the right. Those are the different combinations. So I'm just going to show them with the ones with the drawing, and then the ones with the words are done the same way. And these I find to be actually a lot easier than the binomial. It's like kind of the same idea, but you don't have to worry about the wording, whether it's fewer than 3 versus 3 or fewer, that sort of thing. You can always do the same thing here. So you look for first, you want the lower bound. So we're looking for the lower bound of our shaded area. So our shaded area starts with 2.11 and goes on to infinity. So for our lower bound, we're going to put 2.11. For our upper bound, it's infinity, but there's no infinity in the calculator. So the way you handle that is you put 1 E99, in other words, 1 with 99 zeros after it. So a lot of students don't know this EE button, so you'll do second and the comma for the EE. They also sometimes get confused because the function is EE, but only one E shows up there, so assure them that they've done the right thing. It's just an E. They don't need to put it in there twice. 1E99, just type the 99. Because all of section 7.1 is referring to the standard normal curve, then you keep the mean at 0 and the standard deviation at 1, and that's what a standard normal curve is by definition. And then like with the binomial one, you do the paste. It'll show it to you with the parentheses around it. If anyone has the TI-83, this is the sequence and how they need to enter their numbers in, because they won't have that little wizard asking for those things, and then enter, and you get the answer. And in most of these cases, you just get the answer here and you enter it, and you don't have to do anything else to turn it around. Then we've got area to the left. So back to second VARS, normal CDF. And now our lower limit is negative infinity. So we're going to do negative, and this one you have to enter this negative sign here. If you enter the subtraction symbol, the whole thing won't work. You'll just always get an error. So then it's negative 1 E99 for the lower limit. And the upper limit is the number, the z value that you're given here, negative 2.52, and again has to be negative and not the minus sign, negative 2.52. Keep the mean as 0, standard deviation as 1, paste, enter, and you've got your final answer right here. Part 3, it's area between. These are the nicest ones because you don't have to worry about the positive or negative infinity part. Second vars, normal CDF. Your lower is your lower, 0.93. Your upper is your upper, 2.05. 0, 1, paste, enter, enter, and you've got your answer. Lovely, love these. Okay, and then part 4, you could do it as an area to the left and an area to the right and add them together, or you can do it as the area between and subtract from 1. That is what I prefer because it's fewer steps. And so second vars, normal, CDF. Your lower is 0.98. Your upper is 2.08 and paste, but now you have to do 1 minus because this just calculated the area between the white area. We want the gray area. The total area under the standard normal curve is defined to be 1. So now, just like we did in some of the binomials, now we do a 1 minus, go up and grab the number it just calculated, enter, enter, and that's the final answer. And the hard part with this one is for the student to remember to do the 2-step thing. Luckily though, most of these it's grouped by, you do a bunch of to the right together, and then you do a bunch of betweens together, and then this one has like some of each, and then we get to this one. It's saying to use table A2 to find the z-score, and you can do that using the table, but you can also do it using the calculator. And but this is asking for the z-score given the area. So this is the opposite of what the previous ones were. So for that, it's still second vars, but now it's inverse normal because we're given the area. And so if the area to the left is 0.52, now unfortunately, oops, messed that up. Okay, area 0.52. This one has this tail left, center, right, so this could be a very easy problem, but most of the calculators don't have that. The standard TI-84s don't. I think maybe the TI-84 like color version has that, but the regular ones that Trio has and that most students have do not. They default to left. So if you're given area to the left, then it's fine. You just put in the area, and you won't have this row asking you about the tail. And you paste, and then it gives you the answer, which is, in this case, 0.05. But looking for another one that is like this. Z-score for area to the left, 0.87. That's the same. Here we've got z-score for area to the right is 0.72. So since the calculator can only do area to the left, we have to calculate the area to the left from the area to the right. So again, we're going to go inverse norm. And then this is kind of a nice thing because we can do this calculation right here in the area. So if the area to the right is 0.72, then the area to the left is 1 minus, oops, keep messing that up. Okay, area to the left is 1 minus 0.72. And we can just do that in there. We don't have to do it separately and put it in there. And then we have it correctly set up to calculate area to the left and paste. And then it gives us the z-score of negative 0.58 and right here. Oh, also it's good for the students to be aware that when you're talking about z-scores, a z-score can be positive or negative and is usually between -3 and +3. It can be a little higher or lower, but if they get a number like 50 or -50, they've probably done something wrong because the z-scores in these problems are generally not any more than +3 or less than -3. And then also they need to know that the probability is always going to be between 0 and 1. And so if they get any of these if they get an answer that doesn't make sense, for example, if they accidentally were doing inverse norm when they should have been doing normal CDF, and they end up with a probability number that's negative, then that doesn't make sense. You can't have a negative probability. And then pretty much always the very last problem in section 7.1 is one where you find the z-scores that bound the middle something percent of the area under the standard normal curve. And so that one again is going to use the inverse norm because you're looking for the z-scores. So we'll go into here, second vars, inverse norm. And the area, the way you're going to get the area, you want a normal curve that has 88% in the middle. So that means there's 12% in the two tails combined, which means there's 6% in each tail. So we're just going to calculate the left tail. And so since each tail has 6%, then the left tail has 6%, but the area is 0.06 because it always has to go in as a decimal. We leave everything else alone and paste. And we get negative 1.55. But because it's symmetrical, we don't actually have to do the calculation for the right. It's going to be the positive version of the same number. So that is the simplified way to do this. So the part that they need to do is, and usually it helps to draw it out, is to draw a curve, draw the lines, put 88% in the middle. They know the whole thing is 100%. So that leaves them 12, and then if you ask them how much is in each tail, they can usually figure that out as 6%. So that's how I've learned how to teach this one particular problem. And so that's all of 7.1. 7.2 is going to be similar with one small difference, so I'm going to do that in a separate video.